Okay, welcome back. I'm sure you all enjoyed that break that you were after. You were able to stretch and do all sorts of exercise activities and got the energy back. I'll continue with where I left. As you are aware, you have to double click on this STM32 Cube IDE and it will start to load all its contents, its files on the background. And it's loading. I can see on the background. Once it's loaded, I will show you and start from there. um, won't be long. So it's still loading on the background. Just one sec. Sorry, close the STM Cube ID. So every time when you start as fresh, it has to do a lot of internal checks. There you go. So there it is. So now I'm going to show you to create a new project, how to create the first project that you got your hands on. So all you have to do is go to File and New, and there are plenty of options in New, so which one to choose? So I will show you. The C++ project, if you choose and write your code, and it will generate the executable file, but that's only meant for this particular PC or for this computer. You can't use that code to use it in the target board, which I connected from the board to the IDE. So you have to choose STM32 project. Before going into there, let's check again to see my connected board via the USB cable is on the port list in device manager by doing just this device manager, and let's go to device manager and I'll show where it's connected with the target board. It will be under ports on COM, and I'll show you it's on ports. You will see STM microelectronics ST-Link virtual COM port on COM3. That's my targeted board. So yes, it's connected, and I can see all the lights lit up. It's on. Okay, now I'll show you how to create the project. So File, New. Since we are creating project on the target, I'm going to use STM32 project. So click on that. This will start to do a few things on the background, setting up files, all the necessary needed files for the project. And once it's ready, then it will move on to the next step, which is a target selection, where you're going to link your targeted board to the IDE. That's the next step. It's still thinking and loading on the background. So just bear with me one moment, please. Once it's ready, yeah, there it is. It got scared of you all, guys, so it started to work. That's good. So it's initializing to select the target. Once it's ready, then you will get the target selection window, and you can link your target board to the IDE. There it is. This is the target selection window. You can directly choose a microcontroller to write direct program to it, but today we are using the target board, which is Nucleo F411RE. How to choose that? So you have to go to the next tab as board selector, choose that, and then on the commercial part number, because as you know, after you buy the board, it will be labeled in the front so you won't miss it. So I'm going to type the board name. It's Nucleo F411RE, and there it is showing. So click on that and come here, click on that, select. As soon as you click here and select, the next button will be enabled, and also you will get to see the features of the STM32 Cube IDE. It's documents and resources, its data sheet, and if you want to buy through IDE, you can also put through your purchase. So once you click here, just click next, and this will bring you to set up the project name. So I'm going to give, being the first project, example 1, we are on day 5. So I'll leave it at that as the project name, and I'll tick the box to use default location. This is where I link the workspace directory to the project, and these three options you need to be mindful of. So you need to select targeted languages as C, so we're going to write our code in embedded C, and the targeted binary type should be in executable, so you need to have an executable file to use it. And the third one is targeted project type. What type of project are you going to do? STM32 Cube has all the graphical interface and everything. That's for more advanced projects, but since I'm going to teach you from scratch, we have to choose empty. So I'm going to choose empty on this one. So choose empty, and then once you're done, click finish. This will fetch all the files, necessary files, and put everything in together, and as you can see already, the project folder started. So example 1 underscore day 5, and that will contain all the default files that generally links to this IDE, to that project. So by default, in the source files there will be 3 files, which after it finishes I will show. So this is the project tree window or a project explorer, where you can keep all your project related files in here. It has includes, which has all the header files. It has inc, it has src, where that's the main source folder, where by default you get all these 3 files: main.c, syscalls.c, sysmem.c, and the startup code. And there is a separate session to learn about startup files, but just to give you a brief, startup files are the ones that run before your application code to make sure everything is set properly, so they do that bit, but I will elaborate that as in a different session. So you don't have to worry about startup right now. So all you have to do is now is to double click on main C and go to the editor window. So do the double click, and in a while this will open into the editor window. This is where you're going to write your, or type your code, I should say. Type your code in your editor window. Being opening first time, it will take a while to see through all the checks, and there it is. So this is the main C program, and this is how it looks. All these in slash with stars, these are all for nodes, so you don't have to worry about. This is for authors. Like when you're working in real big projects, this really helps because it tells who written this code and who is this author, and what it is all about. So just a bit of a small introduction to the code. So it is really necessary to keep, but if you think it's too much, then I can delete it, but for the moment I'll just leave that up because we're going to concentrate what's down here. So because I'm going to teach you from scratch, I'm going to delete everything inside, and I will show you from scratch. Okay, so I deleted everything, and now I'm going to show you the first step, or the first process in the example 1. ARM Cortex M4 allows printf style of debugging. What is printf style of debugging? I'm going to show that to you. As most of you be familiar from your C programming days, printf is the one you use in your code to view the outputs in the console itself, in the console window. So this is the console window where you will see the status of your code, and this is your outline window where as soon as there is some changes, you will see the added files as I progress, as I type. Okay, let's start on with I'm going to write my first printf, and always remember always remember that semicolon in the end. That's very important. And we're going to say hello to the world. How surprising. Okay, so every function should return with a value, so I mentioned that here. And once this is written, then you can go and right click and build this project just to get a start. Right click, build project, and this will compile and gives you the status in the console window. So this is the console window, and you will see all the different files, NAGB, EABI. So if I go here, I can give you or show you some extension .elf file. .elf is the executable linker file which you needed when you want to burn that into the target board, which is what we are after. We need the .elf format. So it's checking all the code, and it's coming up and showing me the status as 0 errors and 2 warnings. Because we're going to do the debug mode, and this is about real-time debugging, so we need a bit of help other than just writing a printf statement there. So what is it? If you go back to the presentation that I shared with you today, you got to use the debug trace so that you can start your debugging in your code. So you can get this piece of code from the STM microelectronics or from the data sheet. So it is readily available, so it's nothing new. Copy the whole code. You can do two ways. You can do a right click here and then copy and then paste it in the IDE, or if you're more versed with your keyboard, you can hold Control C, that will copy, and go back to your IDE, and you need to go on to syscalls. This is syscalls. This is where all the header file lives. So this is where you're going to paste the debug code so that you can debug your writing code. So under #include all the #include files, Control V, paste that copied code from the presentation. And this is the first step done. So that's good. So now you're going to include this function. You're going to call this function to write and send characters. So Control C, and you have to scroll down to go to int_write. What you have to do is, to start here, you need to comment this line. You are not giving input output through put character, so you need to, oops, sorry, I didn't mean to do that. Just go back, int write, go here, click /, will make that line as comment. Then here we're going to call the function that we just pasted there. So Control V, and we are declaring the pointer, so it is the pointer, and don't forget that semicolon. Save it and do another build. Right click, build project. This will check both the files and give you the status of that printf statement that you just written. Okay, still it's showing two errors, but not to worry. That's not a problem. Two errors and one warning, so we will reduce that. But as a programmer, it's always nice to see that uh, when it lights up with error, that means you're going to learn something new. So something happened, you're going to rectify that, and how you're going to do that, you have to go to that location where it says the problem is, then you just go there and make the following comments and change everything, and then you can do wondrous things. Okay, so it's showing an error with the implicit declaration of ITM send character of pointer plus plus with the, okay, I have to check the previous code what I written here on the top. Void, okay, just one sec, I'm just making sure I haven't missed anything while I copied. There is, I just cut this and pasted instead of copy paste, so that's one of the problems. So copying this function name, going back to the IDE, you got to declare the function, yeah, and then save, and once again compile and build the project. So this will eliminate that error that we saw when you were watching last. It's checking the background and all the files, so it's checking and just about to create .elf extension file. As you can see, the build project status goes here, so it has to go through all the way to 100 to see the status. At the moment it's 26%, so just be a little bit more patient and you will see that, yay, there it is. So it's 0 errors and 0 warnings, but still in the console window we are not able to see any output of saying that particular word what you typed, hello world. Why is that so? Well, all you experts may be knowing, but it's my duty to tell why it is not showing. So when you use a printf statement, you have to include that library file. Yes, please don't forget the library file, which is hash include stdio.h, and save and run again, which means build and compile the project. So build, right click, build the project. So again, this will go through the project build, and when it hits about 26%, it will start to show the ELF file, and it will give you the status of the errors and warnings. So that's all well and good. So still you can't see any output. So still we are in the C++ perspective. Now I'm going to show you how you can set the debug settings. You have to set this before you start to debug. So to start the debug, you need to get this first, 0 errors and 0 warnings. So that's a good sign. So that means your code is ready, error free, no warnings. Now you can go and debug and check more internally. So to do that, example1 underscore defi, right click, this time choose debug as and go for debug configurations. So click that. Debug configuration window will open. So go to the very end where it says stm32c/c++ application. Double click on that, and that will open the configuration window where you have to create a couple of settings. So by default, when you click on that, you'll get the name example1 underscore dev5 debug, and the project name is we are working on the project 1 example1 dev5, and by default that links with the .elf file. To show that, because as you remember, we created the target earlier as ESD. I'll show you desktop ESD ARM Cortex M4 demo. You go in there, and we created this folder target, and we created these files. So if you go to example1 and debug, and there it is, those 3 files will be generated after you click on build project. These 3 files will be generated, but before then nothing will be there on. So you need to link this example dev5.elf in the application. That's what you see here, debug/example. So that's what it's done. So once that's done, then go to the next step, which is the debugger. Click on that, and you have to do a couple of changes here. Go to the interface and choose ST-Link. That's your target board, so you need to choose ST-Link. And then for the console window to view your output, you have to select the serial wire viewer and click this enable, and that will set the output parameter so you can watch your output in the console window. So once you've done these 2 steps, just simply go here and click apply, and then click on debug. This will tell the IDE that you are moving from C++ perspective window, which is this, to debug window, which in a minute you will see. It's doing its thing, so it's launching debug mode. It's on 4% right now, so it has to link and check everything as it progresses. So a bit of patience will won't go astray. So 15%, it's still doing its checks. 70%, 79, still going and still checking. 79, still going, and it's waiting for the debugger connection on 89%. And here it is. So it will ask for it to switch from C++ perspective to debug. So click switch, and once you hit switch, then you automatically see this different format of files, which you will see in a fraction of a second. Yes, it finished its debug mode. So we are in debug. How you can tell, as you can see on the right 2 side, so that's the debug window. When you click on switch, it generates that and brings the debug window, so you can see all these newly added variables, breakpoints, expressions, disassembly, register, everything, and this will be generated in debug, and that's the C++ perspective. So this is how you get the files in and how to get your debug mode activated. So we are ready, and that's the debug window. That's where you can see all your files. So now I'm going to enable how to view your output. So to do that, you need to go to window, go to show view, and you need to go to SWV, that's serial wire viewer, and in there you have to choose SWV ITM data console. ITM stands for instrumentation trace macro cell data console, which is nothing but to trace ports. So click on that, then you will see this extra tab added in the console window. It's where you're going to view your output. So click on start trace. So this will start to trace your output, but before doing that, go and configure the trace. So one tab in front of it, click on that configure trace, and it's linked to port 0. So you have to enable this port 0. Please remember port 0, and then click OK, and we are all set. So we started to trace. So now let's see what happens. So these 2 are very important buttons in your debug mode. So this allows you to run the program in debug mode. This allows you to go step by step, meaning line by line, and this one goes step over, meaning it can um, skip one line and go to the other. And there is another option called step return, which skips entirely the whole function and goes out of the function, so which I will show you when that button highlights. So for now I'll click on resume to run to see what happens. I clicked on run, nothing happened, so still we are not able to see the hello world. Why? Okay, many of you would know, and if you're an expert you already know why that's happening. It's because whenever you start to generate a printf statement, all the messages sits in a buffer location, which means they are in a temporary location, and you need to flush them out to show it on the console window. So in order to do that, you need to use f flush std out. So once you do that, you will be able to see the output on the console window itself, but because I included this new line, it won't show the output straight away. So you need to kill the project and then rerun it. To do that, you have to terminate and relaunch. So click this option, terminate and relaunch. This will come out of the debug mode and it will switch to C++ mode, check for errors and warnings again, and then it will ask you to switch to debug mode. Then on the debug mode you have to go back again and click the run button, and that will show the output on the console window. So bear with me for a few more seconds. It's on 4%. Okay, the target is set with .elf file. Yeah, that's a good sign. So it has 0 errors and 0 warnings, which means it accepted that line of code, and it's saying it's ready to be used for debugging. So let's wait for a couple of more seconds. Sometimes it automatically goes to the debugger. Yes, it does. And if it doesn't, then you can go to debug. So this is same as before. It asks for you to switch from C++ perspective to debug perspective. So just what I did. After you click switch, you get all these extra goodies we call variables, expressions, breakpoints, registers, live expressions, everything it's there. And also the SWE ITM data console, everything in there. We already set this, so we don't have to do. So because we put that f flush, all you have to do is go back here and click run again, which is resume. So as soon as you hit run, look what happened. Magic. Yes, you have written your first code and you have seen the output, and it's right there. And voila, you know how to write a piece of code and how you can bring your input to the output. So this is all about programming. So what you write inside the function code should be appearing on the console. So this is all about programming. How exciting is this? I'm super excited. I hope you are as well. And I'm sure by the end of 30 days you will be a better professional than where you are. So stick by me and I'm going to show you more. It doesn't stop, but I'm so excited to see first time hello world. So I couldn't stop myself to break in to show the things, but yes, that's a good start. So now you can see hello world. So far you learn how to create a project, how to eliminate all the errors and warnings, and how to set up your SWE ITM data console to see the output, and how you change from C++ perspective to debug, which you get all these options in there. Now I'm going to add further along to show a bit more about putting a loop in there to show you what happens if I create a loop in. So just bear with me for a sec before I start doing that. So you got to int main of void, and I'm going to include a loop, loop, a while loop. Always make sure that if you open curly braces, make sure you also close, otherwise you'll get plenty of problems by not doing that. So once you've done that, then go to save, build the project again, because this refreshes and put everything back in track, and then you have to go to debug to show you what happened with this while inclusion, the loop, while loop. Yes, so I'll show that in a tick. Please bear with me. Okay, it did the build, the compilation, so it come as 0 errors and 0 warnings, which is happy that it accepted the while loop. So now let's go to debug to see and view our output. So to do that, again you need to go there, right click and debug as, and go to debug configuration, and again the IDE will ask you to switch from so before it will ask which program you want to debug. So we are on example on day 5, choose that, and then you already set these two tabs, you don't have to worry. So click on debug. This will take you back to debug window. So now the IDE will ask you, would you like to switch from C, C++ to debug, and you have to click switch, and that will take you to the debug window. So it's nearly done, 89%, nearly done, waiting for debugger connection, debugger connected, 93%, still detecting. It's about to connect and ask you that message, just bear with me. Okay, I don't know what happened there. It didn't ask me to change or switch. We are already in debug mode, as you can see. So now all you have to do is open this console window and leave it open. You already set your configure trace. So all you have to do now is to check what this while loop does. All you have to do is go in there and click. Well, I'll show you step by step. So you go into step into, one click, you wait, and after a few seconds, if nothing happens, do another few clicks and see what happens. So now it executed the hello world. So if I do a full run, see what happens. If I click resume and run, let's wait. Voila! So this is what the loop does. What is actually a loop? A loop is something continuous that never ends. It keeps going. So until I ask to stop, it won't stop. So it keeps printing world hello, hello world, world hello. As you can see, it's not really even typing, not grouped as a word. It's showing us world hello instead of hello world. So there is a space missing, and that's about the \n line, which I didn't use, so that's why you see that, which I will rectify that in the next program that I'm going to show. So far I have shown you how to create the project, how to change from program mode to debug mode. Program mode is nothing but C, C++ perspective mode. Debug mode is where you come and see your output at the console window on the SWITM. So this is the difference between just one printf statement and the use of the loop in here. So I just wanted to point out there. And with this, I may be able to break and give you 5 minutes break. And when you come back, I'll show you the second section, and we're going to learn about uh, call stack and watch points. So please go and enjoy that 5 minutes break, and I will see you back in a tick.